This video covers Module 8, Part 2, which is about the quadratic formula and the discriminant. And the quadratic formula is probably something you've heard of or seen before. So the quadratic formula helps us find solutions to a quadratic equation of the form ax squared plus bx plus c equals 0. Again, what this is doing is this is finding the x-intercepts, if they exist, because I think we saw in our last video that some of them could be complex, and we'll talk about what that means in this video. So if I'm finding the solutions of a quadratic equation, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And somewhere on TikTok, there's a video of me singing this to the theme of Pop Goes the Weasel, so happy hunting. But this is a formula that you will need to memorize and know how to use. But we don't want to use it all the time. We want to be selective about when we use this formula because it's kind of clunky. There's a lot of substitution you're going to have to do. So let's compare it to how we used to solve equations. So let's factor this the old way and use the quadratic formula and maybe even complete the squares like a little bonus. I didn't think about doing that. So we can compare all three methods to solving these equations. So my favorite way is factoring. So every time I look at a trinomial, I think, okay, can I factor this? What are the factors of 6 of AC that add up to b? And in this case, it would be x plus 2 times x plus 3. And I set each of these equal to 0. So I'd have x is negative 2 and x is negative 3. That's my solutions. And that didn't take a super long time. But we can't factor everything. What's nice about the quadratic formula is that it works for everything, even things that appear prime, right? It works for everything. So if I want to solve this, I start by labeling my ABCs. A is 1, B is 5, C is 6. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And I recommend writing this out anew every single time until you feel like you really have a good hold on it and really have it memorized. So x is negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 6 all over 2 times 1. Now that we've substituted in, we simplify. X is negative 5 plus or minus the square root of 25 minus 24 all over 2. So x is negative 5 plus or minus the square root of 1 divided by 2. X equals negative 5 plus 1 divided by plus or minus 1 divided by 2. So x is negative 5 plus 1 over 2, which would give us negative 2. And x is negative 5 minus 1 over 2, which would give us negative 3. Look at the amount of math we had to do to get to the same endpoint. So my first recommendation is always see if you can factor. My second recommendation would be see if you can complete the square without getting a fraction, because this one would give us a fraction. So why don't I complete the square in orange over here, just so you can see why on this example I wouldn't want to complete the square, because I've got to do 5 over 2 squared. That gives me a fraction. So if I was completing the square, so we compare all three methods, this is a bonus. I know this isn't in your guided notes, but x squared plus 5x is negative 6. I add 5 over 2 squared to both sides. That means this left-hand side is going to factor to x plus 5 over 2 squared. So I have negative 6 plus 25 fourths. Negative 6 is equivalent to negative 24 fourths. So I've got x plus 5 halves squared equals negative 24 fourths plus 25 fourths. So I have x plus 5/2 squared is 1/4, and I square root both sides. So I get x plus 5/2 equals plus or minus 1/2, and I subtract 5/2 from both sides. Gosh. And I hope you see a lot of similar numbers are occurring, right? X is negative 5/2 plus or minus 1/2. I'm going to get the same answers when I add these and simplify. All three methods get me to the exact same answers. It's just depending upon what's going on with my ABC values, some ways are less complicated than others. So this video is going to talk about the quadratic formula. So we're going to practice using that. But on exams, quizzes, problems, when you're asked to solve these, there's 3 different ways you could solve them. And I want to make sure you know how to use them all. So let's use the quadratic formula to solve this. And the first thing that has to be true is that they're in ax squared plus bx plus c equals 0 form. So I'm going to label my ABCs. A is 6, B is negative 5, C is negative 4, and I substitute them into my equation. So x is negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is a negative 5, plus or minus the square root of negative 5 squared minus 4 times a times c all over 2a. So x becomes a positive 5 plus or minus the square root of 25 minus 4 times 6 is 24. Times another 4 gives me 96. It's going to be plus 96. All over 12. So I get x is 5 plus or minus the square root of 121 over 12. Well, 121 is this 11 squared. So I break this into 2. I have x is 5 plus 11 over 12, and x is 5 minus 11 over 12. So x is 16/12, which is 8/6 or 4/3. We want to simplify that down. And x is negative 6 over 12, so a negative 1/2. Those would be my 2 x values. For this next example, I have 4x squared equals 8x minus 1, and I need this whole thing set equal to 0. So I'm going to move the 8x and the 1 to the other side. So I have 4x squared minus 8x plus 1 equals 0. My a is 4, my b is negative 8, and my c is 1. So x equals negative b, which is a negative 8, plus or minus the square root of negative 8 squared minus 4ac all over 2a. So x becomes positive 8, because 2 negatives make a positive. Plus or minus the square root of 64 minus 16 all over 8. So x equals 8 plus or minus the square root of 48 over 8. Now the square root of 48, I'm going to need to factor that. That's 4 times 12, which is 4 times 3. Oh, it's 16 times 3. So I can write this as 4 squared times 3. That would give me 4 root 3. So I have x is 8 plus or minus 4 root 3 all over 8, and I could pull out a factor of 4. So x is 2 plus or minus root 3 over 2. And I can write this as 2 separate x values if I wish, or I could leave it. Because it's the radical, I can't really simplify it to solve for a simplified fraction or an integer. So for that case, it's okay if you leave it in this form. So here I have 2 irrational x-intercepts, whereas before in our first example, I had two rational x-intercepts. And the example before that, I had two integers. So we got integers, we got rational numbers, which are integers as well, and irrational numbers. Next, I have 9x plus 3 times x minus 1 equals 8. This is going to require a little bit of legwork because I do have to FOIL everything out first and get it set equal to 0. So I have 9x squared minus 9x plus 3x minus 3 is 8. 9x squared minus 6x minus 3 is 8 because I combine like terms, and then I subtract 8 from both sides. So we're going to go ahead and label our ABCs. I've got A is 9, B is negative 6, and C is negative 11. So I have x equals negative 6 plus or minus the square root of negative 6 squared minus 4ac, make sure that whole thing's under the radical, all over 2a. So x is a positive 6 plus or minus the square root of 36 plus 396 all over 2 times 9, which is 18. So I have that x equals 6 plus or minus the square root of 432 all over 18. 432 is a pretty big number, but I know it's going to be divisible by 9. So I've got 9 times 48. 48 is 16 times 3. So I have 4 and 4 and 3 and 3. Those are my two perfect squares. So this is going to be 12 root 3 because a 4 and a 3 come to the outside and a root 3 is left behind. So I have x equals 6 plus or minus 12 root 3 over 18. I can pull out a factor of 6. 1 plus or minus 2 root 3 over 3 would be our final answer. All right, a little bit of a simpler ABC. So here our A is 1, our B is 8, and our C is 5. And if I was approaching this not telling you that you needed to use the quadratic formula, I'd first see if I could factor this. Well, I can't think of any factors of 5 that add up to a positive 4. So quadratic formula is a good way to go. It's a clunky tool, but again, it works for everything. So that's why most people like to use it for all purposes. So I have x equals negative 4 plus or minus the square root of b squared minus 4ac all over 2a. So x is negative 4 plus or minus the square root of 16 minus 20 all over 2. Well, if I take 16 minus 20, that's a negative 4. That's going to be an imaginary number. But we've finished Module 7, so we know how to work with those. X equals negative 2 plus or minus I. So I have two imaginary x-intercepts. Well, what does that mean? Give me like 2 more slides and I will show you. So an important part of working with the quadratic formula is what's under the radical. That b squared minus 4ac part, we call that the discriminant. And based on what the discriminant is, that tells me how many x-intercepts, how many solutions I'm going to have to my quadratic formula. They're either going to be rational, irrational, or complex. So, for example, if I have a negative number as my discriminant, here our discriminant was negative 4, If I've got a negative number, I'm going to get two complex solutions, two imaginary number solutions. If what's under the discriminant is 0, I'm going to have one rational solution. If what's under the discriminant is positive and not a perfect square, we're going to have two irrational solutions, and we saw that. In this example, it's positive, but it's not a perfect square, so I got two irrational solutions. And then if I have a positive perfect square, I'm going to get two rational solutions. And we saw that in our very first example. What was under b squared minus 4ac, this became 1. That's a positive perfect square. So I had two rational square roots. The same thing happened here, where what was under the square root was a perfect square. It was a 121. Square root of that is 11. I also got two rational solutions, or x-intercepts. Okay, so these are 4 possible outcomes based on what's under our radical in the quadratic formula. And because we're solving these, we're setting them equal to 0, we're finding the x-intercepts. If I have a negative discriminant, then I've got no real solutions, meaning I have no x-intercepts. This is what happened in the very last example we just did. If my discriminant is 0, there's only one real solution, because I would have some number plus or minus the square root of 0 over another number. You only have one option. Plus or minus 0 is just 0. So then you'd only have one x-intercept. And if I've got a positive discriminant, I have two real solutions. They might be irrational. They might be rational. But then my parabola, which is the graph of our quadratic, right, is going to cross our x-intercept, our x-axis twice. This is my x-axis, in case anyone needed a reminder. So let's take a look at a few discriminants and see the types of solutions that they have. So for this first example, we aren't solving it. What we're doing is we are using the discriminant to determine the number and type of solutions. So I still need my ABC. A is 6, B is -1, and C is a +1. So if I want to find my discriminant, it's just the part that's under the radical, that b squared minus 4ac. I'm going to have -1 squared minus 6 times 1. That gives me minus 4 times 6 times 1. That gives me 1 minus 24. That gives me a -23. So because it's negative, I'm going to have two complex solutions. That means there are no x-intercepts. Next, I've got x squared plus 4x equals -5. I need this to be set equal to 0 in order to label my ABCs. So I have b squared minus 4ac. That gives me, again, 16 minus 20, which is -4. So I have two non-real complex solutions. Next, I got 4x squared minus 12x plus 9. So A is 4, B is -12, C is 9. I'm going to have -12 squared minus 4AC. That gives me 144 minus 144, which is 0. So I'm going to have one rational solution. And we could see that too if we factored this. This is going to factor to 2x minus 3 squared. So there's only one term to set equal to 0.